Hi, everybody. Well, welcome. I'm Fleming. I'm the Vice Chancellor for Research, and I want to welcome you all to the Energy Core Symposium. I want to start with some thanks. How many parents are here? Put your hands up. I want to thank you for trusting us to send your kids all over the world and bring them back. And now the students. You stick your hands up, please. There's about 30 of you, and I want to thank you for being willing to indulge in these adventures and to bring your remarkable intellects and energies to the amazing posters that I saw outside. These should be published somewhere as a collection, I think. Let's do that. Yeah. And finally, there are sponsors. Some of the local sponsors are here, and I'd like them to own up to who they are. Thank you. I know that our students are very popular with their hosts and are always keen to have more of the same. And so without the sponsors, this program wouldn't work. As you know, it's a paid internship. The idea to look at energy and climate issues and solutions in a global context. To realize that what might work here is not going to work in India. What might be the issue in Hong Kong isn't necessarily the issue in Munich or Copenhagen. And so the idea came most forcefully to me when I was standing in Hong Kong looking at these giant apartment buildings that line the road going to the airport. And Professor Ng from the Chinese University of Hong Kong was with me, and he said, "See that's the Great Wall of Hong Kong. Those buildings are so high, they've perturbed the airflow in the entire region. And the wind no longer blows the pollution away from the factories in China, it just sits here." And I thought, well, I can tell people that, obviously, but seeing that is different. And seeing what Professor Ng is trying to do about it, which is redesigning the development in the city of Hong Kong so as to create the airflow, which we have one poster about that, was really what made me think this was an opportunity that I couldn't let pass. So that was really the origin of the program. And I will do some more thanks afterwards. But let me also say that the timing of this symposium, as you come together, is quite perfect because the Intergovernmental Panel on Climate Change has just released its fifth report, fifth assessment, and I'm not going to give you a long lecture, but I'd like to note some of the things that they say. Warming of the climate system is unequivocal, and various things that are not so good are happening. The ocean and the atmosphere have warmed, snow and ice have diminished, sea level has risen, and we see changes in extreme weather and climate events. And these are happening all over the world in different ways. It's extremely likely that we caused this. Continued emissions, in other words, business as usual, will cause further warming and changing in all the components of the climate system. That's why our students are so important. I'm probably not going to be around to see the consequences, the real consequences of this, but you are, and I need you to own this problem for all of us. The problem is mostly carbon dioxide emissions, according to the IPCC, and that what has already been done is going to persist for centuries. So we have a multi-century climate change need to deal with this issue. So this is unreadable, but it just shows you this is the different contributions, the different gases. So this top one is the carbon dioxide, so the burning of oil and coal and gas. That's by far the largest contribution, and there are a series of other greenhouse gases that have smaller contributions. And this is what we've been doing. If we added CO2 at the historical rate, we'd be traveling along this line. This is the temperature, the average temperature, relative to this period, 1861 to 1880. But you see, we've jumped. We're not even following that. We've jumped up. Here's 2010. And we're headed off into uncharted territory. And probably most of us won't be here in 2100, but you never know. This is really a big issue. I'm going to let Paul talk a little bit more about that. Let me see what else I need to tell you before I introduce Paul Wright. We started off, I think, with 19 students going to Hong Kong and India and Taiwan, and then that was 2011. Then last year we had more than 30 students going to Ghana, Brazil, China, Germany, and again this year 30 students. We want to give everybody the chance to do this. That's why the internships are paid. We don't want the students to make a choice between earning money for the summer, for the next year, and doing this program. So we wanted to not just cover the costs, but enable you to make a little bit of money. And we have placements with academic partners, like National University of Singapore, or IIT Kharagpur in India, or Academia Sinica in Taiwan, or the University of Sao Paulo in Brazil. And we have company partners, some even in the Bay Area, and NGOs, like Waste Enterprises, an organization that works with rural communities in Ghana, Blue Energy in Nicaragua, and Modroof in India. As I mentioned, our partners have been really, really positive about this, and I think you can see from the posters that our students have benefited from this experience enormously. It's quite a process to pick the students. We had around about 90 applicants this year for the program, and so I need to thank the faculty advisors, some of whom are here, who helped us make the selections. We've had great help from the steering committee of the Berkeley Energy and Climate Institute, and I need to especially thank Chris Somerville, who helped inspire the program, as Chris, and has been very generous with his contacts around the world, since we try to match the skill set of the students with the labs they go to. We want to make it as effective an experience as possible. So these are personal matches that we work on. And Chris has been very generous in helping us with contacts, especially in India and Brazil. And later on, he's going to moderate a panel with the students to talk about their experience. As I said, partners, especially Matthias Craig. I don't know Matthias. There he is in the back from Blue Energy. That's the Nicaragua Renewable Energy and Clean Water and Sanitation Services NGO. And I don't think they're here, but two of our own graduates who started a company, Imprint Energy, Brooks Kincaid and Christine Ho, are not here tonight. I also need to thank Lawrence Berkeley Lab for helping us. And my staff, who worked really hard. Cassie, where are you? Outside eating. She joined my office earlier this year and has helped with all of the placement and stayed in touch with, I think, with all of you. So let's thank Cassie for all of the work that she did on our behalf. And Kaya Zirt, who gave me these notes, was much too modest to put her name on this, but she also deserves a round of applause for all of her efforts. And now I'm passing the torch to Paul Wright, who has taken over the leadership of the Berkeley Energy and Climate Institute, and the program will live in Becky, as we call it. And so Paul will be taking charge of this program, and he's going to say a few words.
Thank you. Thank you. Thank you. Thank you, Graham. Oh, okay.
I think that's you on the microphone.
That's right. Sorry, I had the microphone cord. Right. I wanted to thank you for coming tonight. We have a full auditorium. I especially wanted to thank the students that spend this time in these beautiful places. Since it's an evening presentation, I thought I'd be a little bit entertaining for you. And I wanted to show you, as you were going to places like Ghana and far-flung places, I spent the summer here getting the Institute started with Graham. And as I was driving around in the Berkeley area, I started seeing these signs. Did you see these signs during the summer? Some of you, they're rather engaging, and they're produced by Prudential Insurance Company through actuarial data, right? So you know that these are probably really accurate bets on what's going to happen. So let's look at that middle one, just for fun. Somebody in this room could live to be 150. Who's it going to be? You're going to be, okay, so good. What's your name? Alan. Okay, Alan's going to live to be 150. Good-looking guy, looks like he goes to the gym pretty often. No? Okay, how about Jeffrey? You go to the gym. Let's say it's going to be you. Okay, so which year were you born in? 1989. Okay, so while I'm showing a couple more slides, add 150 to 1989. Okay, could you do that? Okay, good. You need my calculator, or could you do it in your head? Okay, that's pretty good. That's close. Now, women often... Close. I said it was close. It wasn't right. But anyway, females generally live longer than men, right? So let's pick on Heather's close by. Do you mind telling me what year you were born in, Heather? 94. Okay, you got the same assignment as him. You got to add 150 to that, right? So bear that in mind because if that happens, if Heather and Alan live to be 150, the data that Graham just showed you is going to have some scary consequences. This is real data from the New York Times and the Observer and the Economist magazine, and you can see here that sometime in the late spring, while you were doing your final exams, we crossed this magic marker of 400 parts per million. This is data that's collected at the top of a mountain in Hawaii, so it's really clean data. It's the best data there is. And what I'm going to show you in the next slide, I'm going to take this square and put it down in the bottom corner of the next slide, which is here. That experimental data, you can't argue with that. It's not about modeling. It's just people, Keeling, Ralph and Charles Keeling have been taking this data since the Second World War. That data is now compressed into this rectangle here, and this orange squiggly line is the data. And all I did with my students, some of whom are over here in the corner, we just took that line. There's a quadratic equation on the NASA website. We just extrapolated that line, and it's going off the top of this chart. Okay, back to Alan and Heather. What did you say? You're going to 150? What did you say? Huh? 2001. Okay, 2001 it is. Okay, the 10, 20. It's about here. Actually, it's about this line. Well, actually, I didn't even go that far. It's off the top. So it's over 800, right? Okay. Heather, you're looking at, if you live to be 150, it's 800, right? This is scary data. Everybody in this room who's in the age group of being 20 Even if you live to be 100, you're going to be in these carbon concentrations of about 600, 700. And just recently, at the national labs, a guy called Bill Fisk was just doing simple experiments on how people had decision-making capability and their general feelings and their stuffiness and ability to concentrate. Once it goes over 800 in a room, your decision-making powers begin to deteriorate. So how about if that's like the air on the outside, right? So some of Graham's data combined with this shows that what you guys have got to do is invent policy, invent science, invent engineering to bend that blue curve over to here, so at least we may not go much above 450 to have a healthy planet. Why is this happening? I think everybody knows this. It's the coal plants that we've been building ever since the Industrial Revolution in England, which began around the period of 1780 to 1820. And after Britain started their Industrial Revolution, by the way, when the parts per million were about 280, the American expansion occurred, especially after the Second World War. And now China and India and the other developing countries, they want exactly what you have. Sitting in a beautiful air-conditioned room, going to the coffee bar downstairs, wearing nice clothes, driving a $3 car. They want growth. They want growth like we've had. And so to do that, they're building many, many coal plants. Already there are more coal plants than planned. Despite how bad things are, 1,200 coal plants are planned in the next few years. And as you can see here, coal emits 133% more CO2 than gas. So we've had a slight respite in the United States from the discovery of shale gas. And oil also emits a lot of carbon, but not as much as gas. And now China's actually surpassed the amount of US in those figures that Graham just showed in terms of annual CO2 production. So this room of people are the best people in the world now to try and solve this problem. And we have, over the last 2 or 3 years especially, began to put many programs together. And when I say we, I'm talking about the whole of the campus, led by Graham and the other deans and folks like Kaya and Cassie who have made these programs happen. There's the Cal Energy Corps that's been going on, as you know very well. In engineering, we just started the first engineering undergraduate degree. And Heather, you were in my class that day, right, when we kicked that off. The first 25 freshmen have arrived and they're starting energy engineering. In the business school, there's this terrific program, actually, which helped kick off that company that Graham mentioned, Imprint Energy, and Emil is in the room here from Imprint. He's at the back there. He was one of the people that was lucky enough to work at Imprint because we started this program between the business school and engineering to start these new companies where MBA students and engineering students work together. There's the Berkeley Energy and Resources Collaborative. About 3,000 graduate students are enrolled in that, and undergraduates are very welcome to join in the work there. There have been new courses that have been started. This particular semester is on carbon sequestration. There are many graduate student fellowships that are being funded, and I especially wanted in red font here to illustrate that at Professor Somerville's organization, the famous Engineering Biosciences Institute on the corner of Oxford Street. I'm sure, Chris, there are many opportunities for undergraduates there. He's nodding. My students came at the front here, especially Martin Starr and Rich Winslow. We're recruiting some undergraduates to carry on the Imprint work, so if you want to talk with these guys afterwards. We're doing a lot of work in policy also, and Danny Collingwood here is leading our energy work in policy. So there's many ways in which the undergraduates can plug in. And this slightly busy slide just summarizes that Becky is integrating the whole of the campus. And if your personal interests are in governance policies or laws to accelerate, say, the penetration of renewables into the grid, please come and join us, talk to Danny, and begin to get some undergraduate experience in how you can help those policies change. If you want to work in biofuels, see Professor Somerville. If you want to work in energy efficiency, see myself or David Koller, many of those colleagues in that area. In the College of Chemistry, we have a lot of work going on in carbon sequestration. The Dean of the College of Natural Resources in the audience, a good friend of mine, Keith Gillis, is over there. If Keith could put his hand up. applause, I think, is coming up. And his colleagues, very, very strong in climate, how climate influences agriculture, how climate influences water resources. And so I think Keith and his colleagues will be very welcoming of the Cal Energy Corps people to stay and do work in that area. A colleague from the education department actually is there, who also would be interested, I think, if you want to think about how to educate the next generation and educate general population, perhaps some of our politicians in Washington, about carbon and its influence. So please come and join us in these various programs. I wanted to end with somewhat of an optimistic note, and I wanted to show you this slide just to show you things are possible. Now, this is a slide which is really only applicable to one day in Germany sometime in the late spring, where it's neither very cold or very hot, but it shows you that the kind of research that you can do could change the way in which that coal problem is phased out, and we could rely on solar energy to provide the world's energy. Just in the middle of that day, in the early afternoon, practically all of the German baseline power was supplied by solar power. And of course, that's a unique, probably an unusual day with a beautiful blue sky. People weren't turning on too much electricity, and they were able to cope with it. But this is a sign of things to come. If we can do something like that, that's going to be a big game changer, but we still need to store that. And so part of my own personal research with these wonderful students at the front and related to imprint energy is beginning to print both small and large batteries to be able to store that solar power in remote regions. And what we do with our research, which you'll be again welcome to join, is print out the current collectors in stainless steel and then use these needles to provide the flow of the different electrode materials, and we investigate the density of the electrode materials and the ionic electrolytes that go with it and how they relate together. So there's a group of projects that you can work on to begin to change the world's energy picture, and I picked out these last three quotes just for fun to end my presentation. Yamani was the one that came up with this rather funny quote that the Stone Age didn't end for lack of stones, and the oil age won't end long before we run out of coal. But he was really just emphasizing that these fossil fuels are here right now, but the age that we depend on that will soon run out. Barack Obama says the nation that can't control its energy sources can't control its future. And Thomas Edison, who was born nearly more than 150 years ago, was saying that we are rather like farmers chopping down the fence around our house for fuel, which is what we're doing, and we should be using nature's energy to do that. So I want to inspire you with those ideas. Please come and join us in the Berkeley Energy and Climate Institute. Thank you for these wonderful Cal Energy Corps experience that you had, and it's a great pleasure talking with you tonight. Thank you for being here. Thank you. I can't remember what's next. Oh, I'm introducing Chris. Yes, sir. Thank you. I got so fired up I couldn't remember what was going on. Now we're going to have a terrifically interactive panel, which I'm very much looking forward to. And we have Jeffrey, would you like to lead your team up to these chairs here while Chris is being mic'd? Oh, you have to. Yeah, I gotta give you mine. It's on. I think we can just put it on here.
It's on. No, I don't have any slides. It's fine. Yep. All right. Is everybody being mic'd up? Or are we going to share? No, it's good. Lots of mics to go around. Okay. Well, the next event this evening is going to be a panel discussion in which I believe, I'm sure, a random sample of Cal Energy Corps students are going to talk about their experiences. And do you have a mic? Well, why don't you take mine? I'll show. How's that?
Thank you.
So we thought that maybe the best way to begin would be for each of the students to introduce themselves and briefly, in 1 or 2, in 2 minutes or 3 minutes, talk about what they did as a beginning gambit. So why don't you begin, Carter?
All right. So yeah, my name's Carter Chung. I'm a mechanical engineering student here at UC Berkeley, and this summer I spent the summer in Hong Kong, working with the Chinese University of Hong Kong, researching what Vice Chancellor Fleming was talking about, how wind speeds are reduced in cities because of the large and dense buildings. And what I was doing was developing a way to predict wind speeds based on the local layout, so that urban planners in the future can use these methods to prevent these problems in the future.
And I'm Jeffrey Whittaker. I was doing my work in Brasilia, Brazil, the capital, at a synthetic biology lab that's run by the government. And so we were taking soybeans and modifying them so that the seeds would have a better oil content, so they could be used for biodiesel. Because if you just take a normal, unmodified soybean seed and use that for biodiesel, it can run into problems under cold temperatures where the oil will start to freeze up and get muddled up and really viscous and completely ruin your engine. And so we were basically modifying the seeds using genetics to produce a soybean that wouldn't have any of those problems and would have only the fatty acids that we want.
Hey, I'm Troy Hodges. I graduated this May in Conservation and Resource Studies, and I was fortunate to work in Ghana with Waste Enterprises, a sanitation and energy company that's out to revolutionize the way sanitation is done. And I helped them optimize their process for turning liquid sewage into a biomass fuel. And yes, that's the poop scoop on that.
Hi there, I'm Heather Hughes, and I'm a second-year mechanical engineering major. And this summer I was working in Taipei, Taiwan, in a lab that was working on dye-sensitized solar cells. And specifically, I was looking at how altering the composition of the electrolyte in the dye-sensitized solar cells, how that can affect some.
Hi everyone, I'm Leo. I was in Ahmedabad, India this summer working for Modroof, a company that takes cardboard waste and makes it into roofing for the urban poor. And what I was doing is basically streamlining the manufacturing process while I was there to make it faster and make better panels, roofing panels.
Hi, my name is Suman Dong. I'm a junior studying chemical engineering in Spanish. And this summer I was in Bluefields, Nicaragua on the Atlantic coast working on the solar power work equipment system. During the summer in Nicaragua, especially in the park, there's a lot of problem with drought and people won't have water for a while. So we basically worked on using solar panels to provide energy to pump up water for our irrigation system.
So it was very diverse. Some of you worked in leading edge basic research labs, and others sort of worked in developing economy, low input types of innovations. And so I wonder whether anyone wants to sort of volunteer an insight you had from your experience about sort of what the opportunities are for innovation in the energy sector, or something like that. Does anybody want to have an idea?
Well, one thing for me that was really cool was studying biofuels and optimizing a feedstock for biodiesel in Brazil, where that's the one country that has a sustainable biofuel industry. And so it was really cool just to be studying something that could be the key to resolving all those issues that Paul Wright was just talking about, and in a place that's already had so much success in that field.
Yeah, Brazil's kind of amazing. They get 40% roughly of their transportation from biomass and 85% of their electricity from hydro. So it's a very, very green. Exactly. Of course, they're blessed with almost unlimited natural resources in some way. So it's interesting to speculate on who else could actually do anything comparable to that. Mm-hmm. How about another story? Anybody else got an insight from?
Sure. I think one insight I discovered working in developing countries that, a lot of these countries, they're in the process of industrialization. They haven't, they haven't made all the factories yet. They're not on the level that the United States are. And I think that's why we can have such a greater impact in these places, because as they become more industrialized and they build more factories, if we can get there before and make sure that they're doing sustainable practices, and polluting less, then we can have a bigger impact than just trying to reverse that effect once they're already in place.
Good idea.
I also have comments working in developing countries. For me, it was really interesting because I work around a lot of rural communities, and something that I really got out of working with Blue Energy was that, especially in a lot of underdeveloped areas in the world, the social aspect of development was a lot more important than I thought. For example, just to implement a solar system, we had to do a lot of basically asking the people to see if they actually want the system, and see if it was feasible, and see if something that we thought were good for them was actually good for them. Because in the past projects, I guess we've seen cases where we would design and install something for the families, for the rural communities, but they don't use it because it doesn't fit in with how they live their daily life. So it's really interesting to see how the social aspect is a lot more important than we think.
Yeah, some years ago I was on the World Water Council, and I remember a person came to visit us from Africa who had been supported by the World Bank to build latrines in villages throughout Africa. And what they discovered was that after the latrines had been built and the construction workers left, the villagers would fill these latrines with grain, because that's what they really wanted was grain storage more than they wanted public hygiene. So it's really important to know what's applicable in a situation. I wonder if there are any questions from the audience to our panelists about their experience, or maybe that's kind of hard. Yes, there's a question.
What about the language barrier? Some of you probably went to countries in which the thank you. So some of you probably went to countries in which the language that's spoken there is not the language that you speak. How did you adapt to that, if you did?
Great
Thank
question.
This is really easy. Sorry, if anyone had that problem. I speak Chinese.
I wasn't in Brazil. Yeah. In my experience, Brazil is a bit tough if you only speak English.
Yeah, so I actually am learning Portuguese and had already spoken a good amount of Portuguese, but still, it's always a work in progress, and you're, especially in the lab, a lot of unfamiliar terms for all sorts of things. But really, it's, everyone's patient. They help you out. A little less so out on the streets or when you're getting on a bus. Yeah. But when in the lab, everyone's your friend, and if you need help, understand something, they're always totally ready. So really, it wasn't, even if I didn't. Actually, Harini, who was there with me, and she didn't speak any Portuguese, but it was totally fine. A lot of our research colleagues, they also spoke a good deal of English as well, since it's such a necessity, really, in today's science world to know at least some English.
Generally true of science all over the world, that in the lab people speak English in general. Mm-hmm. Do you speak Portuguese now?
I understand.
Yeah?
I wouldn't say I go there and be on my own.
Yeah, me either. Is there another question? That was a great question. Yes, in the back. There's a microphone there.
Have any of the experiences that you've had during your internship shaped your future ambitions?
Definitely. So I loved working in the lab. It was my first time working in synthetic biology and working with biofuels. I'd done a lot of kind of big picture stuff in other classes that I'd taken. And it was an amazing opportunity to actually get firsthand experience with that. But I did kind of get the feeling throughout the 3 months that it's really the big picture stuff that really needs to be worked out, the political involvement and just the economical applications that, and just figuring out business plans that will actually be sustainable. And so that's kind of something that I found would be more interesting to me in the future. And I'm grateful for the chance I had to have that firsthand experience. But I feel like the big picture is what we really need.
What's your major? I don't remember.
Chemical engineering.
Okay.
Yeah.
How about somebody else? I think that's an interesting question. In particular,
Yeah,
Heather.
I think for all of us, it's had a really big impact on our future, and definitely things that we won't even be able to see and understand for a while. But for me, I kind of always knew that, I always thought maybe I'd want to work abroad at some point and collaborate abroad. And after this experience, that's really been solidified for me. It was so cool to kind of go somewhere and interact with people who have been educated on the same topic but in such a different way, and to talk with them, just like talking casually in the lab about energy and their ideas about it all. It was like very exciting and inspiring for me, because I think a lot of good can come from that collaboration. So I definitely in the future am planning to work and live in Asia for a bit.
Why don't you try? You found your future in poop?
It's really intriguing to see how many opportunities exist in the sanitation sector, and how you take in looking for energy innovation, and you start with you turn a sanitation problem into an energy solution. So I love seeing that interplay of different fields coming together to solve a common problem. And yeah, it also solidified my desire to work abroad, continuing. I'll next be taking an internship in Abu Dhabi to continue that. And yeah, it was a great space seeing how other people educate in different ways reflect. I ended up networking with this Ghanaian youth environmental movement there, and they had been pushing their own environmental agenda. And it was really cool to see how they were approaching topics with the politics there, and I love that daily learning. So it's inspired me to keep pushing that boundary of alternative views.
Anyone else want to?
Yeah, I think one of the most important things I learned going ahead was that nobody really knows what they're doing. And what I mean by that is that we have all these experts who tell us all these things. Like, for example, with my project, the wind engineers, they said, okay, like if you're going to try to predict wind speeds at a single point based on local urban morphology, it's impossible. You don't stand a chance. And I was able to develop a model for that, and that actually really inspired me. That people keep saying all these things that solar power maybe has its limitations, something might have its limitations, but nobody really knows what they're talking about. And what we really need to do is go and try it, go and find out for ourselves.
Yeah, I had a similar experience working for Modern, trying to build these roofing panels, and it gave me a lot of insights into starting a business. Especially one where you're making a product, because you just got to do it. Is what it comes down to. And the guy I worked for, he was bootstrapping everything, and it really showed me what it means to start a business and to really care about something and like put your heart and soul into it. And it was amazing to me how dedicated he was to the project. But when I arrived there and I went to the slums and I saw the roofing conditions and I saw the trash on the ground, I really understood like how important it was to solve those issues.
So I have a kind of question. Now, my experience in India is, you were in India, right? Yeah. At least in the engineering side, the engineering is very practical. Every Indian engineering student has their hands on all the unit ops for whatever their field is, and I wonder whether here at Berkeley we've gotten a bit more theoretical, and I wonder what your experience was. Whether is your education, directed at the right level with regard to practical application, or?
Well, I'm actually right now I'm a physics major.
Pretty theoretical, I guess.
Yeah, my studies definitely are theoretical, and that was part of why I wanted to go to India and work on this project, because I really had the chance to get my hands dirty and just see, just put my skills to use, and it was really great to see that I could have an impact. So.
Anybody else want to comment on that? How was your education? The relative to sort of what you ended up doing, or what the other people you were working with. What impression did you get of how Berkeley is targeting?
Something that I I don't know if it directly answered your question, but something I definitely learned from my experience was that being in Berkeley, being at a very big research university where there's a lot of focus on inventing the new thing, making things better, and basically doing something new. But when I was working in Nicaragua for blue energy, there was a lot of emphasis basically on using the technology that's already been developed and applying it to areas that needs it, applying it to underdeveloped areas, because when there's already all this great technology out there, we don't, sometimes for basic stuff, we don't need to come up with a new thing, because it's already out there. So for me, learning, basically seeing and learning how we also need to put emphasis on using the things we already have and figuring out a way, researching a way to make it more applicable, to make it so that it suits the need of whatever area you want to install it in. That was a big lesson I learned from being in Nicaragua for blue energy.
That's a good observation. Anyone else want to try that?
Well, at Berkeley, I know sometimes there's a reputation for frequency of protests. And so it was fascinating being in Brazil at one of the most heated protests that the country has ever seen. So it's really interesting to compare and contrast what was going on there. So that was politically just there couldn't have been a better time to be there. I learned so much about just the culture, the history of Brazil to go along with all the technical things that I was learning. So.
The government was very responsive to those protests, as I remember.
Yeah, a little, sometimes too responsive.
I think there was another question over here when
I wasn't aware that Brazil was as green as they are. I would love to hear more about it.
So we actually, even outside of the work, we would travel a little bit. We had a chance to, Irene and I, we went to a place called Foz do Iguaçu. It's kind of out in the middle of nowhere, and there's a dam there called Itaipu Dam, and so that's kind of one of the hydroelectric sources that Chris Somerville was talking about. It supplies about 20% of the entire country of Brazil's energy, and it supplies about 93% of Paraguay's energy. The reason being that Paraguay's cities are so much closer, and it's a smaller country as well, so that a lot of the electricity goes there. But still, 20% of all of Brazil, one of the largest countries in the world, all coming from this one dam. And so there's several other dams as well that are contributing to that, plus the huge biofuel industry. So there really is a lot of alternative energy work going on in Brazil.
Yeah, you remind me actually of Peace Corps workers. And I've known several Peace Corps workers who have gone to different countries, and with the idea of educating and helping them. And actually, they get a lesson in living simply, living on less, and living in harmony with nature. Did you see much of that?
I definitely lived more simply. Didn't really have internet too often. It was really nice to kind of get away from all that and get away from the consumerism, to not have a car and to walk places. But I was in a big city, so I didn't get sort of a rural feel, which I feel like you might be talking about. But I did definitely live more simply.
I was kind of more close to rural areas. So the area I was living in, Bluefield, it wasn't really rural. It had an airport, but there are a lot of rural communities around that's very isolated. And actually, when I first started interning, we went and made a visit to this nearby community called Symposium. And basically, because there's not very much public transportation that's set up, so we kind of took this motorboat. We went through a jungle and went and visited this family, and there is no electricity. It's not something that everyone has, and then maybe some people have like little things that light up the house. But it was really cool to see how it's like a lot of families, even in Bluefield, they have wells. the people use water from the well. People in the morning you see people pumping up water, and that was really interesting. Bluefields is that at 5 a.m. everyone is awake because in Nicaragua people kind of just go by the sun's time, and by 5 a.m. everyone's awake doing stuff, and then by 9 p.m. and 10 p.m. everyone's like waking up. And there's, even though we had electricity in Bluefield, there's a lot of power outs very frequent. Maybe like every other day there would be a power out. And just a lot of things that we take for granted in our life that when I got to Bluefield, I got to experience, is even running water. The first week that I arrived, it was actually the end of the drought that Nicaragua was having, so we didn't really have running water. We kind of just got water from the well and used buckets of water to take showers. And apparently when it gets really bad, people just won't have water for a week. So it was really cool to see how people, no one has problems because of how they all grew up. And the fact that not everyone has internet in their house, or even a TV, or even electricity, or even running water, or flush toilet. And just seeing the contrast, even though in our world right now, seeing how here in the US everyone has their iPhones and their smartphones, always doing stuff, always emailing, everything, and then there it was kind of cool to be cut off from all of that. And just kind of enjoy the simplicity of life for once.
Yes, another question over here. Oh, sorry, go ahead, Heather.
I had a similar experience enjoying the simplicity of life. It was so nice to kind of go there and just, I found that I wear kind of the same clothes and just do the same thing. And besides my being in the lab from 9 to 6, I would get out of the lab at 6, and I had kind of this whole country before me, and the public transit was so well set up, and everyone was so friendly. I felt so safe that it was kind of like Taiwan was my playground, and so it was a really cool experience to have no other responsibilities and just kind of feel very free and very, it felt like my only responsibility was to experience the culture and get to know the people. So in that sense, I had that same experience.
Yes. I had a question just more about the cultural reception of your guys' work in the different countries. Especially, I imagine most of you guys are all from America, and so I'm wondering, in the more developing countries, was it a harder sell than you might have thought to bring these clean energy solutions? In the more developed country like Taiwan, did it seem more ordinary than you would imagine?
So in Accra is interesting if you're, or in any country where you're trying to talk about sewage and turn it into something useful. We'll just look at you strangely. What? I was all familiar with Everybody Poops. I think there should have been a sequel to that called Everybody Poops Gold. That's how valuable it is. You'd have to work through that initial disbelief, and then well, is it safe? Are you sick? And then you'd have to talk to, no, it's safe, and then you talk about how much value it has, and then people would slowly get on board and be really interested in it. So if you took some time and explained it could work there. You can work here too.
Yeah, it's kind of amazing. A couple of factlets. In India, there's 2 million biogas generators roughly, and in China, there's more than 6 million biogas generators. And so they're not all using sewage, but they're all using some form of waste. And it's a kind of a big part of the energy sector in some countries that's actually not alive and well here yet. We're behind the rest of the world actually in that. You probably know that.
Just another note on that, I found that my being an American tended to lend legitimacy to what we were trying to do. When we would go to the slums, my boss was always really excited to bring me because he was like, oh, they're going to see you, they're going to be like, oh, he's American. There must be some really high-tech solution, and they were always really into it. When I was at the factory, workers would always come to see what we were doing. They'd come over to help me unsolicited and just watch. And so I didn't think it was a hard sell at all. There was no anti-American sentiment that I, perceived. So I had a really positive experience being an American.
There was one taxi driver. We get in the car and we explain, oh yeah, we're from America. And he says, oh, are you a spy? Because of the whole Edward Snowden incident, so everyone was joking about how we had to be spies. But other than that, everybody was was very, very hospitable.
Okay, well, looks like there's one more question. Is it
actually,
tentatively, or is it?
Thanks. I'm actually going to break the rules a little and give a comment instead of a question. I hope that's all right, because I was struck by the slides that Professors Fleming and Wright presented. And I heard a comment from one of you that said, I love being in the lab. And I can sympathize with that myself, but I just wanted to say that in today's increasingly technology-driven world and whatnot, we need people, bright scientists, bright engineers, to be getting into policy as well and really think about these global issues and be able to drive federally funded research or international climate policy and whatnot with a real strong underpinning in your education. So I think the work you're doing is fantastic, and I would just someday consider that path because we need more of you.
Yeah, I think that's what Jeffrey was saying as well. Same thing, basically.
Definitely.
Good point. Okay, well, I think the organizers would like me to bring this to a conclusion. I hope you found that interesting, and I don't know if there's any last minute thing that somebody would like to say, a comment or a concluding remark, or okay.
I think a great thing about the Cal Energy Corps is, well, when I was in Hong Kong, I was in the lab all day. I was in front of a computer all day, and it seems like, why would you send me to Hong Kong if I'm just going to be at a computer? But it really made a difference. At the beginning of my research, stuff just wasn't working, but when I got out there and I just looked at Hong Kong and I observed the city and I observed, why wasn't the wind getting to me, kind of thing. And after that, the work just picked up, and it really makes a difference to actually be there. And that's a great thing about researching abroad.
Okay, well, thanks a lot. I think we can bring it to a conclusion then, and that was really interesting. Thank you for your participation. Now we'd like to invite all the